a quick little review of limits. I took a very interesting one, the limit as x approaches 3 of x cubed minus 27 over x minus 3. It's a cubic, so we had to factor it using a formula. And the x minus 3's canceled out, and you got 27. The second one that we had was the limit as x approached infinity of 4x cubed minus x to the 5th over 4x to the 6th minus 3x squared. Now tell me, what's the greatest exponent of x? 6. Do you see an x to the 6th in the top? I don't. So let's just write 0x to the 6th. Now if you highlight the greatest exponent of x, coefficients, what is it? 0 over 4. Isn't that neat? Isn't that a nice method? You don't memorize that. What was it that you had in algebra that they memorized? Yeah. And it makes no sense, and it's just memorizing. Do you like this? Do you like this where you don't have to memorize? It actually makes mathematical sense. Yeah. 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 Yeah, that's great. All right, so x approaches 2 of 1 over x minus 2. X over 2x. Well, actually, I'm going to write what it's starting with here. 1/2 minus 1 over x. So what you'll do is get a common denominator, right? And so this is going to be the limit as x approaches 2 of x minus 2 over x minus 2. That isn't mathematically working out here. 1 over x minus 2, x minus 2 over common denominator. Do you see why I only write it once, 2x? So then what cancels? So you're going to get 1 over 2 times 2. Yeah, it is positive 1/4. I think yesterday we had negative, didn't we? Positive this time. But that's not the one you're having trouble with. This is the one that's the granddaddy of all the challengers. X approaches infinity of the square root of x squared plus x minus x. Here's the thing. You put infinity in there, what do you get? Infinity. It looks like you get infinity. But this is kind of interesting. This is like infinity minus infinity. Is there a chance that it might be 4 or 2 or? There's a chance. So infinity minus infinity is one of those that it's like 0 over 0. It's called an indeterminate form, and you'll see these in about a week. All of them. This is one of them. So what I'm going to do is I'm going to multiply the top and bottom by something we call the conjugate. You know what the conjugate is? X plus y times x what? Yep. Why is that a good thing? Because the terms x squared, there's no middle term, and then it's y squared. You lose the middle term and you square the outsides. Could that be handy for us? Oh, yeah. So, all right, so when you multiply that out, you get the limit as x approaches infinity of, essentially, it's this times this. What is that squared? X squared plus x minus, what is that squared? X squared, right? All over square root of x squared plus x plus x. Now what? I like it. These cancel out. And so we're left with the limit as x approaches infinity of x over the square root of x squared plus x plus x. Now, this part here, what does that kind of boil down to? What's the greatest exponent of x there? X squared, right? And in the root, does this x do much to this when we go to infinity? Does this x add to x squared very much? Not when you get to infinity. So imagine that that wasn't there. This is essentially x over what plus x? Yes. And so this is going to be a half. You don't believe me, do you, that that's true? Well, let's take our calculators and double check it, see if it makes sense. So here's your very cool problem. TI tools, I'll race you. So you can get their calculator out first. For the calculator, we're going to put in the square root of parenthesis x squared plus x. I don't think I need that square root. X squared plus x. I did need the square root. Let's try it again. Parenthesis x squared plus x parenthesis. All right, maybe yours didn't need it, mine did. And then I have, was that minus x? Minus x. Function look okay? Now let's put in here, let's go for my window. Window's going to be 0 to, let's go 1,000. And I'm just going to go for y, I'm going to go from 0 to 10. 0 to 5. And so when it's graphed, I should see a little bump. And then what? It's not very helpful. Let's try something else here. Let's go back to window. Let's go negative 5 to 5. And negative 5 to 5. Now let's see it. Comes in. There you go. So why is there this gap between negative 1 and 0? It doesn't work, and the reason it doesn't work is because when you take a negative 1, this is going to be 1, and then you're going to add negative 1, you're going to get 0. Square root of that is 0. 0 plus 1 is 1, so that's why that works. And negative 2 works because when you square negative 2 and just add negative 2, you're going to be fine. But if you put in a negative half, it's going to be negative in the root, and it's going to disappear. But look what happens after it. From, the more you go to infinity, let's trace this. What happens to the y value the more you get bigger, 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 bigger? And, yeah, it is 0.5, isn't it? Yep, so that's your limit. Those are some limits that we worked on today.